And welcome back, Mindsetters. I hope you had a nice little break there. Make sure you stick around and do not disappear anywhere, because now we're going to continue with the rest of the session. So make sure you got your pens and pads out and you're making notes. And yes, everyone, I'm seeing your posts and it's awesome. Keep on posting. I'm still looking for the best post. And yes, you'll be getting this awesome Casio calculator and this labeler. And on that note, this is where I hand over to Mr. E.T. E.T., take it away.
I think, Tai, you mentioned someone was wondering about the repeated data or data coming twice or three times or something.
Yes, I think the question was, let me actually find it. Letsu, he was actually saying that this is the first time we've covered it in school. What happens in this if the sequence has a multiple of 2 and a different sequence has the multiple of 4? In terms of, I'm assuming he's saying you're analyzing
size.
2 different sides, yes.
Oh, the size of data. All right, now, because we are talking about the quartiles, that's why I'm using 4 to determine the end. So if I just go back quickly to, or maybe just use this space here, because I'll be using this. I said n equals to 4k. And that is simply saying you've got a multiple of 4, like the 8, the 12, and all that. So all I'm saying is with reference to that, right? With reference to these multiples of 4, all you have to do is, drop 1 back. It will be like adding 3 onto the previous multiple of 4, and or increase it by 1, or increase it by 2. So basically, the 3 points that are in the middle are covered in that sense. And why do I use 4? Like I said, because there is these are quartiles. Okay. Probably if it was quintiles, I would work out something about, with the 5K or something. Okay. So that I hope I'm answering the person who asked the question.
Yeah, no, as I always ask Mindsetters, if you have a question, try and get it as specific as possible and let me know exactly what you guys are looking to find out. Because sometimes you guys ask questions and they're a bit too broad and we're not sure exactly what you want to find out.
Exactly.
But yes, on that note, we've got another one. If you think you want to cover that one as well?
Yeah, let's see that.
Ashworth wanted to find out. Ashworth is also very regular. Ashworth, how you doing? And I just want to say hi to Lucinda and Pleasure and everybody who's also on the page. Yes, I will go through wherever I can. I'll give a shout out. Ashworth wanted to find out. So how do you calculate the 3 number summary? Well, lower quartile, median, and upper quartile from an ogive graph.
All right. This is where we even call it an estimate. But basically, on the ogive, you are going to use 25%. 50% and 75%. Okay, so you read it off the graph. If I can just show you typically what it would mean is that if you have your ogive, an X curve like that, and you've got, say, 100, your frequency goes up to, or rather the data point is 100, all right? So if you've got 100, then right in the middle of that, you could read off, you draw a horizontal line. When you hit the graph, you then drop your line, you can go and read off your value. Let's say in this case, that would be Q2, if this is 50%. All right? That would be Q2. And you'll notice I always start with Q2, because it's right in the middle. So then I move outward to the other quartiles. So these are all the quartiles. So at 75%, you can go and hit the graph again at a certain point, and you read off your Q3. For 25%, same thing. You drop your perpendicular and go and read off your Q1. All right, that would be 25%. Okay, so that's how you read off your quartiles from the ogive.
All right.
Okay. So yeah, the other representations, I think this is a better. In fact, this is the best one to read off the what's name from the quartiles from. The other one is the frequency graph. You can, or the histogram. You can also estimate by working out the areas of the blocks, especially if it's group data. You work out the areas, and then right in the middle, you part the area under the curve or your histogram, it will actually have that shape as well if it's a normal distribution. So with all those, blocks coming in there. So the way you would do it is cut it right in the middle. So for normal distribution, remember your mean value will coincide with your median. It will be exactly the same. Okay. So if the moment they say it's a normal distribution, you can, immediately tell that the mean is equal to, the median. And remember we talked about data that is skewed. So that's when the mean and the median are not equal.
Okay.
Okay. So then that's not symmetrical data. All right. Enough of quartiles. I hope I can move on.
Yes,
I
no, that
wanted
was it,
to-
because you actually just answered another question that I was going to ask from Leandro and Lucinda, because she wanted to find out what did you mean by skewed, and basically you just answered it now.
Oh, yeah. When the mean and the median are not equal. Yes.
All right.
All right. The one thing I want to cover to complete this session is I think you will be expected to look at data. If you plot it as the X value, that's what they call bivariate data. Now, you are measuring the height, and you want to see if there is a relation between the height and the age, of people, that kind of thing. So you will then say, this is bivariate data. You are basically dealing with, data X and data Y. So when you have that kind of data, you want to see how that data, in that data, how the X associates, with the Y. Is it going to be a linear, association or some kind of curved association or something? So that's what I'm highlighting there. Either linear association or a curved association. What do I mean by that? Quickly with a graph, you've got your Y over there and your X there. And data, as you plot it, it comes out. I hope you can see that, my dots here. That data clearly is inclined, and it has a tendency, if you can draw the boundaries on that, it lies between, two, two lines, and you can say this is now a linear data, okay? The association is linear, and of course, later on you'll see that we're interested in telling whether that linear data it's got a strong association or a weak association. All right, the other one would be typically data that is, let's say, coming out clearly in a form that is describing some kind of curvature. So when you have that, the only way to draw the boundary for these things is to, sort of come with a curve. And we say this has got a curved association. All right. And even then, you want to know whether you can actually fit in a certain equation. Or, for instance, in this case, can you fit a straight line equation onto that data? Or in this case, can you fit an exponential equation for that data? That kind of thing. And I think I wanted to cover that. Let me just see. Yeah, a strong and a weak association, like I said, that should actually cover the lesson for today. But if there are any more questions there, I'm prepared to look at that in the last few seconds.
All right, let me scan quickly.
Yeah.
Okay.
Right.
Okay, basically, we have a couple of questions from Pleasure. You want to find out what is the frequency of polygons?
The frequency of?
No, what is a frequency polygon?
Oh,
I'm
a frequency polygon.
Yes.
That I can explain quickly. I'm going to use this space here. All right, let's see. Just extend that. So frequency polygon, usually when you have drawn your histogram, let's say, or your bar chart, all right? The midpoint, let me use the histogram. All right, let's say you've got that, another one over there, another one there. So these are your data points. And now you say to me, this is the frequency, and these are your values, okay? So when you talk about a frequency polygon, you are basically talking about a line graph that is just connecting the midpoints there, okay? That is what a frequency polygon is, because now when you look at this thing, it's more like, you know, drawing the corners of a, you know, the edges of a polygon.
Mhm.
Yet it's just the midpoints of the data.
Okay.
Okay.
In Pleasure wanted to also then find out what is a percentile. But do you think we'll
Okay.
be able to cover that in
A percentile, actually, when we did a cumulative frequency,
percentile? What am I saying? I'm failing to read
percentile
now.
per 100. Remember, centile, that's 100. We divided our data into 4 parts. Now we're dividing it into 100 parts. And a frequency, what do you call it? An archive was a good way of looking at that as percentiles, because we're talking 75%, 1%. So there is a centile part of it.
All right. So, on that note, Mindsetters, I hope you had a great session today. I want to say thank you to Mr. E.T. for coming through. It's your boy Ty here saying thank you for posting. And guys, I want to thank Liberty real quick and say thank you for sponsoring. And this is the part where I say stay tuned and keep on posting on the page. Use the page. But this is where I say cheers and see you next time.